Upon further inspection, a mechanical integrity podcast goes beyond the data and dives into the people, challenges, and stories behind reliability and inspection. Whether you're in the field or in the office, this podcast is for you because mechanical integrity isn't about assets, it's about the people who keep them running. You're listening to episode 5. Boilers were blowing up. Mechanical integrity then and now. All right, Greg. Well, welcome back today. Today, kind of wanted to try talking about the idea of kind of the evolution of mechanical integrity, kind of a then versus now, and maybe kind of what caused us to get to this point. I mean, you're going to have a lot more insight into this than I will, but I want to make sure I want to try and get some of that information out of kind of how did we end up where we are now. So, I mean, for you, from your experience or from your what you've been a part of, what do you think were some of the biggest events that kind of happened that shaped the practices and the regulations that we have, right? Because right now, when we talk about inspection regulations, inspection practices, whatever you want to call them, we kind of have API 510, 570, 653, for our main pieces of equipment. But we haven't always had those. So, in your experience, what kind of drove the development of those?
Well, there were there were safety issues and there are also business issues, right? So 510's been around for a while, a lot longer than 570, but it just again points to piping and the personality of piping too. So I'll get to some of that. But so in about 1984, we had the event with the amine contactor at the Union Oil refinery in Lemont, Illinois, that blew up. That had to do with environmentally assisted cracking being present in there, and that vessel exploding. I think there were like 17 fatalities there, and that was in '84. Then in about 1989, '88, we had the Shell Norco explosion, which was huge. That was in a refinery there where there was a hole that was corroded through in an elbow that allowed hydrocarbons to get out that found a detonation source. And there we had a couple of major considerations. One, of course, was the corrosion issue that I think a lot of it boiled down to an injection quill that had been corroded at the tip, and the droplets that were entering through that were no longer being atomized, and those droplets were causing some corrosion in an elbow downstream. But there were multiple fatalities there. And then around the same time, 88, 89, Phillips Chemicals had a huge explosion that I think killed around 20 or 24 people in Pasadena, Texas. That was due to more work process type of issues and how they were decommissioning and commissioning equipment for an outage. And I mean, these are just a few examples off the top of my head. And then
Mm-hmm.
there was another explosion, I want to say in the early 2000s in Nigeria at the Skidjo refinery where they were processing LNG. Actually, I think it was before that because I know the whole liquid mercury embrittlement. You can also call it liquid metal embrittlement because mercury is not the only element that can cause this problem. And that was in a coal box that sprung a big leak, and it got everybody looking for mercury entrained in LNG. So these things were happening. There are other less big events happening. Plus, our facilities are all getting older, right? Some of these things were built around turn of the century. Some of these facilities, early 1900s, and then from there on, I know API has done I think, a great job, one of the premier jobs of writing codes and standards and RPs to try to help us manage those processes better and avoid those kinds of issues. And then you had OSHA come along back in the, like, say, 1991, 92 time frame in answer to some of those earlier failures. And there were other failures going on too, just again, not as big. They came out with the 1910.119 process safety management rule, which obviously includes a section in there on mechanical integrity. So we saw those things happening. Prior to that, too, and I was an owner operator for many years, and a lot of management, I think, had the initial attitude of, oh, regulations are just going to strangle us. It took a while, I think, for the industry to see that things like mechanical integrity and reliability can not just peacefully but successfully coexist when done right. So anyway, I think at least for us here in the U.S. and simultaneously, I mean, we had the failure in the North Sea of that Oxy platform. That there were a lot of fatalities there, just like the perfect storm. Again, not so much anything related to corrosion or something, but just work processes and the left hand not knowing what the right hand is doing, and realizing too that these failures don't happen in a vacuum. So back in the day, the inspection people were talking with the corrosion materials people, at least in the owner operator places that I worked at, but we weren't always talking with the process people or the operations people. We weren't being synergetic. We weren't being holistic about the way we implemented MI at the time. They kind of did their thing and we did our thing. We knew that how they operated the equipment had an impact on us, but we really weren't working together as a team. So that's another evolution I see we've gone through over the years, is realizing that we need to work together as teams. We need to be more understand the interdependencies of what we do and how that can affect things. And so at API, today now you see because of that, RPs around things like integrity operating windows, which really speaks to how process impacts things. We have 579, the fitness for service document now, which evolved out of that atmosphere. And really one of the organizations that was responding early on to some industry explosions is the American Society of Mechanical Engineers. Of course, there's the famous, I'm trying to remember, the Sultana. There was the infamous Sultana steamboat explosion that occurred on the Mississippi River somewhere between like St. Louis and Memphis after the Civil War that killed a whole bunch of people. And that's, around, and of course we had steam locomotives and other things, and we were seeing failures, boilers were blowing up, and that would, eventually spur some of the boiler rules that we have that came directly into our world, right? Because some of those behaviors and activities, metallurgies, inspection, all that kind of stuff are similar. You can migrate those from the steam industry over to the process industry. Just add a whole lot more chemistry and metallurgy.
Yeah, that's why it's boiler and pressure vessel code, right?
Correct.
Because we had a lot of issues with the boilers in the past. Yeah.
Correct.
Let me back up. You were talking about API. So you mentioned RPs. Those are recommended practices.
Yes.
What is the difference, just for anybody listening that doesn't know? What's the difference between an RP and a standard, or a recommended practice and a standard?
A standard or a code?
Well, the 510 is a standard, isn't it?
510 is the inspection code, and it
The
is a
inspection
standard.
code. Yeah.
There's a
Yes.
pressure vessel inspection code. And so
Yeah. Yeah. Talk
codes,
talk talk about those. What's the differences between those?
yeah, typically speaking, codes are at a minimum what you have to do, and those are usually referenced in regulatory documents or requirements, whether it's OSHA, APSA in Alberta, or the Australians, are in the EU, and the countries that belong to the EU. They have their basic rules. Those are not optional. If you say you do it, you have to do it. and you have to do something. So most people have adopted those, like API, for instance. Those are API is an ANSI accredited organization. Those are considered consensus standards, and that's why you'll see those typically followed. But that wasn't always the case. There was a transition there too, even after the existence of those codes. So for a while in the United States and our territories, whether it's Puerto Rico, St. Croix, whatever, and some states, they would follow the national board rules instead of the 510, 570 rules or 510 rules. But eventually, the national board realized that things like the 510 code were more applicable than rules about boilers for heavy wall reactors, making catalyst reactions for refineries. So anyway, there were these things going on, and so the codes are things you have to do. So if you, in general, okay, there are a lot of but in general, and it's relatively accurate, that a code is mandatory and a RP is a suggested recommended practice you can use to not only comply with the code but work smarter.
Okay.
So they're usually optional. A code's considered by most people a license to operate. If you don't comply with the code, you can be shut down by the regulator for not following the code. The RPs are optional.
Okay. But there's a lot of effort that's put into those RPs,
Absolutely.
um, just because people recognize that there is value, right, in continuing to develop them and potentially. I mean, some of them have moved into standard form, haven't they, or a quote into a code?
They do sometimes shift into a code, but what the RPs do is they give you options to operate smarter. So instead they help you, like for instance, the 510 code has a 572 RP. The 570 code has a 574 RP. So the RPs also help the users of those codes get their heads around the codes better, so that it gives them more direction on how to do it.
Okay. And you also mentioned national board. So I've heard some people say, "Oh, our state is a national board state."
Yep.
What does that mean when people say that?
That typically means that the chief boiler inspector for the state is much more heavily involved in what they're doing. The program has to be approved by the chief boiler inspector of that state, not so in non-code states.
And
But
so in Yeah, and so in non-code states, then who then decides?
the non-code state is typically totally governed by OSHA. So that's a federal entity, right?
Mm-hmm.
Whereas the codes are a code state. Now, you can have code counties or code cities where certain cities in that state aren't covered by the boiler code for that state, or what's called the chief inspector, the chief boiler inspector for that state.
Okay. All right. So I wanted to make sure those were a couple terms that we talked about that you threw out there. So I want to make sure that we at least kind of talk about them and cover them for anybody.
Yeah,
Um,
another important thing is that most operators who fall under OSHA 1910.119, which is based on what kind of chemicals are you processing and how much of that chemical is there, they at a minimum have to follow 1910.119. For us, it's paragraph J for mechanical integrity. And of course, they have a whole lot of, 13 or 14 other elements they have to comply with too. But what I've seen happen over the years is for the national board to gradually turn more of that responsibility over to 510, 570. And in fact, in the National Board Inspection Code, there is a code book for the NBIC. They'll often now say, but we recommend that if you're operating a chemical processing facility, such as a refinery or a LNG plant or even a gas plant in the middle of nowhere, that you follow the more suitable codes like 510 or 570, for example. well, 510, especially pressure vessels. That's the other thing too about jurisdictions is some of them only handle pressure vessels, some of them handle pressure or oversee pressure vessels and piping. So you kind of pay attention to each state and what they regulate.
And so bringing this back to kind of then versus now, I mean, it seems like right way back in the day, you mentioned the steamboat incident during the Civil War. So from there forward, there was probably some level of people trying to figure out the jurisdictional pieces. Is it just that different places, different states, different cities are still continuing to try to figure out how they're going to be governed, or is it you think it's more just they've been grandfathered in different ways? It seems like there's been a transition in a lot of different ways of transition.
Yeah, well, I think another thing that's changed over the years is that we've done a better job of educating the regulators
Yeah, true.
over time, and so they're willing to abdicate. I don't know if abdicate's the right word, but they're willing to let go of certain things as long as they go into a more logical bucket, so to speak. So, like I said, there's the National Board Inspection Code, which, if you went back 15 years or so, they held on to that stuff. Whereas about 15 years ago, we began seeing them let go of some of that and even write it into the code again. We think it's more appropriate to you follow API types of codes for, these types of facilities.
Yeah. Okay. How else have you
Except
seen?
boilers. I mean, the national board and the state boiler inspectors still pretty much hold on to boiler. So if you've got a plant with a code stamp boiler, they're typically going to go through whatever that frequency is every 2 years. They got to have a boiler inspection. And that's usually a combination of the state boiler inspectors' rules, oftentimes being applied by authorized inspectors who work for the underwriters. So usually the authorized, the ASME, the National Board Authorized Inspectors are either an owner operator or an insurer or work for the state boiler agency.
Ha- have you been a part of any of those boiler inspections
Yes,
in the past? Yeah.
yes. Many
Are
years
they?
ago, but yes.
Do they tend to be routine?
Um,
They happen so. I guess my question is they happen so frequently. I've never been a part of it, but I know that they have such short frequencies on those boilers, and I feel like now compared to back in the 1800s, we probably have a bit better handle. Granted, due to the progression in the codes and the standards, but I feel like a 2 year interval seems so frequent based off of what we know now about the way things are designed.
well, yeah, good point. I mean, there are times on certain types of boilers that an owner operator may justify an extension. That usually takes the type of very scrutinized fitness for service, and then you present that to the state boiler inspector, our chief, and oftentimes companies can get a deferral on those, or there's another name for it. I'm trying to, an exception to those if you can justify it. But yeah, I mean, I've been there with them, and they're poking their heads inside the steam drums, the mud drums, the fireboxes. They're looking at the economizers, the superheaters. They're looking at everything, and we oftentimes, and the deaerators.
Mm-hmm.
Remember, those are all part of that too. And we have had industry incidents back. I don't know of any recent ones of deaerators blowing up because of corrosion fatigue cracking and deaerators. That's
Yeah, there's a NACE document out about it, right?
Yeah, yeah.
Yeah.
I think we tackled that a while back and
Mm-hmm.
proved the importance of things like heat treatment. That's another thing too I've seen happen over the years is we've learned, after incidents like where you get failures with hydrogen induced cracking, stress oriented hydrogen induced cracking, or corrosion fatigue cracking, and there are other ones. But we've learned over the years the importance of heat treatment and how heat treatment can get us out of susceptibility to certain damage mechanisms. But then was the heat treatment done right? Was it done thoroughly? Did we get everything we needed to? And that oftentimes was something difficult to manage, because sometimes repairs, even something as simple as a fillet weld on a vessel with wet H2S in it, could lead to a cracking problem because you thought the whole thing was heat treated, but somebody had done some repairs on it in the past. It wasn't really documented well or wasn't heat treated, and you wind up with cracking issues.
Yeah, local heat treatment obviously can have its own issues
Yeah,
of
yeah.
stress gradients.
But
I
it can be a good practice as long as it's managed correctly.
I once had somebody ask me, and I'll pose this question to you too, and see what your thoughts are. But I once had somebody ask me, if cost was not a factor, is there any reason not to heat treat a piece of equipment before install? And I'm not talking local, I'm talking the whole thing, right? If you had an oven large enough to be able to heat treat the entire thing once it's been fabbed up, if cost wasn't a factor, is there any downside?
Not that I'm aware of.
Yeah, right. So it's interesting when you start thinking about it. I couldn't come up with an answer, right? Stress relief, heat treatment causes, solves a lot of problems when it comes to the stress gradients and cracking and all of the other issues that you can create. Um, but it was an interesting question I had somebody ask me, and I had the same answer as you. I don't think I couldn't think of any reason why you wouldn't if cost wasn't a concern.
Yeah, yeah. I mean, I would reserve that for a bona fide metallurgist or
Yeah.
experienced metal or blacksmith metallurgist. Those are the best ones. The blacksmith metallurgists to me are worth their weight in gold. Yeah.
What's the difference between a regular metallurgist and a blacksmith metallurgist?
Well, somebody who's, for instance, gotten their degree in as a welding engineer is going to be much more familiar with the heat impacts on metals than non, and the welding engineers, which I call the blacksmith types, they're going to have in my opinion, the ones that I know have had a lot more hands-on experience with welding, seeing the impacts of welding. That can be a pretty hairy thing. I mean, there are some huge heavy pieces of equipment out there that, in addition or in the absence of heat in service, may have, and chemicals may have some tremendous structural stresses on them, like big trunnions with huge axles on them holding up hundreds of thousands of pounds of weight. I mean, when you consider you start to get cracking in something like that, and you've got to repair it, and then if you've got some temperamental metallurgies out there, that can be a huge challenge. So, like I said, I mean, there's a lot of good metallurgists out there, but they all don't have that practical hands-on experience in the field with some of the heat related issues.
Gotcha. Yeah. I mean, some facilities they have people where their only job is just writing welding procedures. They know the need, the heat input, the flaw. They know all of those pieces so well that anytime they need to do repairs, like that's that person's job,
Yeah,
writing up the procedures.
yeah, and cost is always an issue, right? And that's why over the years I've seen too, we've been learning from one another, and now you see people that are able to affect the residual stresses in a heavy weld by doing temper bead welding, where they're actually using subsequent passes of welding and heat treating and preheating and during welding heating to control the amount of residual stress in a weld.
Hmm.
Or
Interesting.
other things like soaking up hydrogen and then having hydrogen cracking problems later too. But I think we got most of those covered, and there's all kinds of now microalloying that can go into different metals and things like to affect heat treatment, cracking, susceptibility, and corrosion. Like we learned about the residual elements issues
Hmm.
associated with equipment in HF Alky service, right? We
Yep.
learned about the effects of microalloying in high alloy furnace tubes, heater tubes, like in pyrolysis furnaces or in reformer furnaces, catalytic heaters. So I've seen a lot of improvement over the years in these things.
And it's interesting how those learnings that we've had have also driven technology. PMI, the ability to do PMI. I mean, that's such a cool. It's such a for me. I don't know why. I think it's just really cool that you can just take a PMI gun and all of a sudden it just tells you the whole content of your piece of metal. So now, that technology allows us to do 100% PMI in our alkies. Whereas 40, 50 years ago, maybe not having that level of technology, we don't really have the ability to figure that piece out. So now we got to come up with a different way.
Yeah, that was huge. Back when I started, we used to use these things called IDQ test kits, and we had basically one of those big block. What are those? Not 9-volt batteries. You know what I'm talking about? Like a half a brick, and they
Oh,
have.
yeah, yeah, you'd put them in like the little kids cars that they
I
drive
mean,
around like a
yeah, I'm
Star
not
Wars.
these. The ones I'm talking about are like 4-inch square around, and they stand about 5 or 6 feet in, 6 inches high, and they have
Mm.
They used to be in the big floodlights, or in the floodlights you could carry. They'd put
Yep.
those in there, but we used to hook those up to a metal electrode and put some chemicals on a piece of Wattman paper and see what color that turned, and go through different chemicals to tell, hey, does this have molybdenum in it? Does it have nickel in it? But now we have, like you're saying, these different types of test instruments we can use for PMI that are based on different principles. And you have to pay attention to those too, because sometimes some of the most important elements for us to know if they're in that piece of metal or not can't be detected by certain other tools. And the rule of thumb I always use is things like carbon, things like sulfur. If you really need to know the amount of those elements in a piece of metal, then you might have to use something that's more like an emission spectrometer type basis. But then some of the other ones, you can get 90% of what you need, or even 100% out of those. But carbon and sulfur are really important because you can't measure them with the other tools, and you have to really pay attention to technique because there's so much carbon just in the atmosphere. You've got to do a good job of surface preparation and technique. And some of these things, technique matters.
Mm-hmm. Mm-hmm. 6-volt battery is what you were
That's
looking
it.
for.
Yeah,
Six
thank
volt.
you.
Yeah.
Yep. That was it.
So what else? I mean, in your experience, right? You've been in the industry for a long time. I mean, what else has changed as far as mechanical integrity over the years for you?
Well, I think people have gotten smarter and got their heads around looking at things programmatically, because now we're talking programs. And I don't mean computer programs, but I mean the way these programs are structured in corporations and in plants and facilities. Like, for instance, with 1910.119, now you have to have a mechanical integrity procedure or a mechanical integrity document. Now you'll see in most companies, they'll have a corporate level policy document, and then they'll have a local level mechanical integrity procedure document that supports the corporate policy document. So I've seen that evolution happen over the years that I think has helped. I think another thing that's happening today is we're becoming more holistic. We were tending toward hyper specialization, but I think now we've seen the pendulum coming back the other way a little bit and realizing generalists do have an important role. And they're the ones who have to figure out how all this stuff fits together. And then I go ahead, Brandon. Were you going to ask?
I, I was just going to say, do you think that we're realizing that generalists are important, or do you think maybe the drive of having to appease shareholders and keep costs down has driven the need for or keeping a handle on expenses, and so has by from that then caused us to just have more generalists, and our generalists are having to just figure it out.
It's a combination of those things. I
Yeah.
think one of the big changes I have seen, I don't think I know, and I'm glad you framed it the way you did, is we see less and less mentoring going on. People are just being thrown, oh, you have a certificate, that means you can do it. Oh, you have a degree, that means you can do it. Just throw you out there, and we've lost the mentoring, which means we're losing critical thinking skills. We're losing the ability to capture past learnings and to pass those on so that people can have better critical thinking skills. And there's a myriad of reasons why I think that's happening. But again, the hyper specialization, I remember I read an article in Harvard Business Review about 10 years ago that was talking about this. And they said, we need we're afraid we're going to lose the generalists, the people, because imagine the generalist is usually going to be a specialist in some area, first of all. And one of the other things too is I think we undervalue the generalist. We think they don't add value. They're not really working. They're the general guy. They don't understand the difference between a face-centered cubic crystal and a body-centered cubic crystal and metallurgy or whatever. Oh, they don't know Ohm's law, if it's an electrical type thing. So, but usually the type of person I'm talking about is going to have a strength in a particular area, whether it's mechanical, chemical, whatever, or a really seasoned inspection person, but they're going to understand how all this stuff fits together. And so they're going to help us create effective overall mechanical integrity or fixed equipment reliability programs. And now enter the enterprise asset management programs. So now we have computers. Back when I started, we didn't have computers at our desktop, and now too we have with that CAD programs and the ability to create drawings and to manage drawings and to store drawings and things like. In the old days, we had blueprint machines, and I could always smell those things going down the hall with the chemicals in them. And you come out with these 3x5 sheets of paper with, the essentially the equipment drawings on them, or maybe some PFDs, PNIDs. So that's another thing that's happened too with OSHA coming along. Now you have requirements to have up to date P&IDs, process and instrumentation diagrams, and people are being forced to understand the thermodynamics and the interdependencies in these units and how they operate. And I'll tell you, I think RBI had a huge risk-based inspection had a huge positive impact on the industry because it forced people to try to understand how these things play on one another and lead to equipment degradation. So, and the other thing too is don't underestimate the value of the SME. So I see another potential pitfall is we become so dependent on the latest shiny rock, which right now is AI, that you can't get everything out of AI. When you get it out of there, you got to validate it, make sure it's credible. But then we use models to be better predictors of how long a piece of equipment is going to last. And then now we have on-stream monitoring. We look at reliability operating limits or integrity operating windows, whatever you want to call them,
Mm-hmm.
safe operating limits, all kinds of stuff out there. Really, really good stuff with a lot of good promise. But if the generalist isn't there to help people understand how this stuff all fits together, we're going to lose the effectiveness, and I think we're going to lose efficiencies. You're going to see a lot of rework being done because we painted ourselves in the corner. Before we started this big, let's say it was an automation implementation, say an enterprise asset management program, but if we didn't understand the work process from beginning to end and how it comes full circle, we may be doing a lot of rework and wishing we'd have, say, created our equipment hierarchies differently, our naming conventions. People talk about, like, one real popular tool is SAP, and they talk about functional location numbers on equipment. I've seen people have to go back and take years to totally redo the way their equipment was organized to effectively implement an initiative. But they could have anticipated if they had the right people engaged in the beginning, but they
Well,
didn't.
or they didn't know, right? I mean, or they didn't know. I mean, how many companies out there do you think, if you asked them if they, knowing now what they know, would they have changed the way that they set up their SAP, Maximo,
Absolutely, a
ERP,
lot of them.
whatever, right? Like,
Yeah,
yeah, at the time when you set it up, you're like, all right, this is the best this is the best option we have. It may not be the best, but the best overall, but it's what we got for right now. And as you start building those things, I mean, they become behemoths and so difficult to try and make those changes after the fact. It's really difficult to have that foresight, 10, 15 years out of how you're going to be using it and what it's going to look like.
I had a good buddy ask me the other day, "Hey, Greg, because there's people that naturally debate over different aspects of technology. I'll just use an example. The generic failure frequencies in API RP 581, the RBI document. Hey,
Yeah.
we think we're going to go to this other technology that calculates it a different way, right? And they're still not systematizing their circuits correctly in the refinery. I'm like, we got to get the blocking and tackling right first, guys. Okay. Let's get the blocking and tackling right first. Let's get our heads around this stuff. Then let's move. And this, that reminds me of too often we try to be efficient before we're effective. And when we do that, we may catch ourselves doing the wrong thing faster.
Yeah. Yeah. I mean, RBI has been, I'll call it a buzzword. I think people, maybe it's losing that piece because more and more people are moving towards it, as opposed to, AI is a real buzzword. But I can't tell you how many times I've had people come to me and say, hey, we want to start an RBI program. And the first question I ask, here's the list of things that you need to be able to do that. And, they may not have they're missing U1 forms. They're missing design drawings. They're
Yeah.
missing some of the basic pieces, or, they're still trying to get their PNIDs updated, to match what they have. There's a lot of things that you got to get, as you said, the blocking and tackling in place first. Going back real quick, you mentioned generalists. It sparked something in my brain. I'm reading a book right now by Reid Hoffman, called Blitz Scaling, and so he's a VC guy, venture capital guy, and he was part of Airbnb and LinkedIn and whatever. And it's interesting you talk about the role of generalists, because in the book he talks about how if you're trying to get going and trying to get started, having a generalist or a group of generalists, he feels is so much more valuable than specialists, because you can give a generalist, right? We're putting people into groups here, but being able to take a generalist who can kind of do a little bit of everything. If you're trying to develop something into being more like developing a mechanical integrity program, specialists are important to be able to deal with those nuances and like what are the technical pieces that we need. But the generalist is there to be able to understand how everything is involved, how all those different pieces touch each other. And that's kind of what he was getting at in the book, is having a group of generalists to be able to scale something up is important, because they can do that, they think that way, they can see that way. And then once you get through a certain point, then you start bringing in some of the specialists to help drive more of the, I'll call it the technical piece. So it was just interesting that you called out generalists, and that was just a part that I had just gotten through in that book. And then the SME piece, I think we're starting to see, I guess I don't know. In the past, did we have the types of SMEs that we have now, or did we really truly have a lot more generalists back in the day?
Oh, no, we had SMEs and we had
We did.
specialists. Oh,
Okay.
yeah. And if you look at things, if you look at models, predictive models, those predictive models need to be acid tested by the SMEs in that
Mm.
area, right? And the generalist at some point will get engaged from, how does all this stuff fit together? And then your costing engineers or your cost people, which your generalists may have that kind of person there too. But at the end of the day, the juice has got to be worth the squeeze, right?
Yeah,
And,
always.
and so where I see us moving today, and what made me think about this mainly is financial management, but it's in these predictive models, identifying uncertainty in the model and then managing that uncertainty based on the criticality of the decision that needs to be made with that information. So sometimes it's important to get really accurate or maybe even precise, but most of the time it's probably not. And it's understanding when it's worth it to be more accurate and when it's not. But that also, to me, says I got to have a good model. I got to have a model that's considering the things that could affect the output or the answer so that I can manage this thing better with this information and this answer. It's just that I don't want to be any more accurate than I need to be because I don't want to spend any more money than I need to in order to achieve the desired level of reliability or safety.
I mean, the crux of that, right, is fitness for service, level one, two, and three assessments, right? I mean, level one assessment, you don't need a lot of information. You're looking things up in a table or on a chart or a graph. You're looking and comparing. But then you get to a level three assessment. If you don't, if you fail the one, the two, and then you get to a level three, I mean, you're going through full on FEA meshes. Now that level of accuracy, that level of precision goes up, and to be able to figure out if where you're at. So I think that's a really good way of saying that, of figuring out, saying that you want to have the right level of accuracy for the right level of reliability.
Yeah, yeah, that's basically you want to achieve whatever level of reliability. Let's say I want to run my chemical plant or my refinery at a 95 or 97% reliability, but I want to spend as little money as possible to do that. That's
Mm-hmm.
fair. That's fair. With this level of safety, and naturally, I want to have a license to operate. I want to do it safely. That's all. Those all need to be considered together, and that's fair. I think what's happened, to come full circle back to where we started in this conversation, is if we look at, if we understand what we want to achieve from the get go, that is going to frame a lot of what this generalist who's putting these things together really needs to be aware, has to be aware of. Here's what we ultimately want to accomplish, right? Now let's put together something that's going to make that work. Another thing that I think gets lost is when people are coming up with these big integrated software programs, which, by the way, is pushing holistic thinking and holistic integrated management, is you got to think about how people work. Because at the end of the day, these initiatives have to be sustainable. And if I'm going to be pushing this down on top of people that they're pulling their hair out trying to make it work, what good is that? They're not going to do it. They're going to look for workarounds. They're going to look for shortcuts. I mean, I've heard these kind of complaints about it, about things like, well, I don't want to mention any software programs, but you can fill in the blank from the biggest, from enterprise resource planning and ERP perspective to an enterprise asset management perspective. Those things get more complex, but the people up at the top that are making these decisions, a lot of them have no earthly idea of how the troops in the field, the ground level people, what they have to do to make this happen. So I think a good generalist is going to think about that too and help build work processes that actually make these people on our programs more effective and more efficient.
I totally agree. The number of times that I've heard people complain about their programs and they say, "Well, this is what we got. This is what we were handed. We can't do anything about it," just because executive level or somewhere in that area was sold on certain features, and they haven't been in those folks haven't been in the trenches in 20, 30 years. Things have changed. So yeah, I totally agree with you on that.
User experience is huge. User
Hmm.
friendliness, user experience is huge.
Yeah, it's massive. So all right, so to finish out here, what do you think, for looking to the future, what do you think would be a good piece of advice to give to, let's call it, asset integrity engineers, inspectors, somebody just coming out, maybe just coming out of college, just coming out of technical school, whatever, just got their cert, knowing what you know now compared to 25, 30 years ago, what would you tell those folks as they start their journey in mechanical integrity? What to look out for, what to pay attention, what type of attitude, what would you what type of advice would, like, because we've talked about if we knew now what what you knew then. What advice would you give to folks now?
Well, a lot, but one of the big ones up front is if these facilities were operated the way they were designed to be operated, if they were designed correctly, we wouldn't be seeing the failures and the problems that we are seeing. So pay attention to what goes bump in the night. Understand that equipment failures typically rarely happen because of one thing. Usually there's a series of things that break down. Find out who the qualified people are that you can go to. And I don't mean qualified by certificate, but qualified by experience and proven performance, who you can go ask the questions of when you need to. And don't make decisions you're not qualified to make. Nobody's making you do that. Go find the right people or the right sources of information to help you do that. And the other thing too that I'm concerned about going forward is the role of data. I think data is vitally important. It's very important. But data in the absence of knowledge, wisdom, discernment can be very dangerous. We need to know context. Again, don't go get data that isn't going to have value. I see people oftentimes recommending doing some type of inspection or buying some software program because they fell under the spell of some slick salesperson. Make sure you find some mentors that you can grab onto, some sources of information you can grab onto to help you with your critical thinking skills.
Those are all very, very good pieces. I think the last one, finding a good mentor. You mentioned it earlier in this discussion that mentorship isn't something that's happening very often now. But I think having a good mentor is something that can help you so much, whether it's a mentor that's in this field, a mentor personally, professionally, whatever. Having somebody to be able to use as a sounding board and to talk through decision making, building your skill sets, working with a person. I think having mentors is like really key. Now I come from a past of coaching, so obviously I'm going to think that mentorship is important. But I really do think that it's something that is can help turbocharge people in not just their careers but also their lives too.
Yeah, I think two other things that are even more fundamental, Brandon, but they go hand in hand, is to have a passion about what you do and have a good work ethic. And don't get so in a hurry that you sacrifice quality of whatever it is that you're doing.
Yep, that's exactly right. That's exactly right. All right, Greg. Well, as always, it's good chatting with you, and until next time.
Thanks, Brandon. Good chatting with you too, buddy. Looking
All
forward
right.
to it.
Yeah.
Take care.
See you. Bye.
Have a good one. Bye now.
Thank you for listening to Upon Further Inspection, a mechanical integrity podcast. This episode was co-created by Inspectioneering and Core Solutions. Our producers are Nick Schmoyer, Jocelyn Christie, and Jeremiah Wu. This podcast is for informational purposes only and does not constitute legal or professional advice. Listeners should seek their own qualified advisors for guidance. If you enjoyed this episode, please join us next time wherever you listen to your podcasts. Until then, stay safe and stay informed.